Good morning and welcome back again. I'm Miss Daria and this is Science Equals Fun. In the previous sessions, we talked about graduation of elements properties. We talked about atomic size and electronegativity. Today, we're going to talk about metallic and non-metallic property. You may think that elements are classified or divided into two kinds, but in fact, they are classified into four kinds. What are they? Come with me. The four kinds are metals, non-metals, metalloids or semi-metal. We can say metalloids or semi-metals, and noble gases. What's meant by metals? Metals are elements which have less than 4 electrons in their outermost energy level. Non-metals, they are elements which have more than. So you have to consider that in metals we say less than, in non-metals more than. More than 4 electrons in their outermost energy level. Metalloids are elements which have the properties of both metals and non-metals. Noble gases, they are elements have no positive or negative ion. Now let's start talking about metals. During the chemical reactions, metals tend to lose their outermost electrons. What I mean by saying outermost electron, I mean electrons in their outermost energy level. And change into what? Lose electron and then change into what? Into a positive ion. Why? Why do they do this? To reach the electronic configuration of the nearest noble gas. Preceding them is a periodic table. Positive ions carry a number of positive charges equal the number of lost electrons, and when we call them positive ions and not a negative ion, positive ion because now in this case after they have changed into ion, the number of positive charges, which is protons, is more than the number of electrons. So we call it positive ion. So we call it positive ion because the number of protons is now more than the number of electrons. So we call it a positive ion. One more thing you need to know about metals, metals have less than 4 electrons in their outer shell. They may have 1, 2, or 3 electrons, and they tend to lose these electrons during the chemical reaction. Like sodium, sodium has 1 electron in its outer shell, and it tends to lose this electron during the chemical reaction, and it changes into a positive ion with positive charge equal number of lost electrons. So it will have 1 positive charge. You may ask yourself, so sodium ion looks exactly like main atom. Why? To reach the electronic configuration of the preceding inert gas. Calcium has 2 electrons in its outer shell. So during the chemical reaction, calcium tends to lose these 2 electrons and they change into a positive ion with 2 positive charges. Aluminum have 3 electrons in its outer shell, so it will tend to lose, during the chemical reaction of course, it will tend to lose these 3 electrons and change into a positive ion with 3 positive charges. You may have noticed that aluminum ion looks exactly like neon atom. Why? This is the whole purpose for changing into a positive ion to reach the electronic configuration of the preceding inert gas. So what is meant by positive ion? It is an atom of a metallic element which lost 1 electron or more during the chemical reaction. So positive ion, it's an atom of a metallic element which lost 1 electron or more during the chemical reaction. Now let's talk a little about nonmetals. During the chemical reaction, nonmetals tend to gain electrons and change into a negative ion. Why? To reach the electronic configuration of the nearest noble gas. Following them is a periodic table. Negative ions carry a number of negative charges equal the number of gained electrons. One more thing you need to know about nonmetals. Nonmetals have more than 4 electrons in their outer shell. They may have 5, 6, or 7 electrons, and they tend to gain electrons. Like nitrogen, nitrogen have 5 electrons in its outer shell. So during the chemical reaction, nitrogen will tend to gain more electrons. It will gain 3 electrons and change into a negative ion. Why we call it negative ion, not a positive ion? Negative ion because it will gain electrons, so the number of electrons will be more than the number of protons. So we call it a negative ion. So nitrogen will gain 3 electrons and change into a negative ion with a number of negative charges equal number of gained electrons. You may say that the nitrogen ion looks like the neon atom. Why? Because this is the whole purpose for changing into a negative ion to reach the electronic configuration of the following inert gas. Another example, oxygen. Oxygen has 6 electrons in its outer shell. So during the chemical reaction, it will tend to gain more 2 electrons and change into a negative ion with number of negative charge. How many? 2 negative charge. Of course, equal number of gained electrons. You may notice that oxygen ion looks like a neon atom. Another example, fluorine. Fluorine has 7 electrons in its outer shell, so during the chemical reaction, it will tend to gain 1 electron and change into a negative ion with 1 negative charge. Negative ion. What's meant by a negative ion? It is an atom of non-metallic element which gained 1 electron or more during the chemical reaction. Examples for metalloids or semi-metallic elements. They are located in P block. Examples like boron, silicon, germanium, arsenic, antimony, and trillium. Okay, keep this on your mind. You may be asked about boron, silicon, germanium, arsenic, antimony, and trillium. Now let's talk about the gradation of metallic and non-metallic property through the periodic table. Okay, in periods, by increasing the atomic number, the metallic property decreases and non-metallic property increases. How does this happen? Each period starts with a strong metal, and by moving its periodic table from left to right, the metallic property decreases till we get the metalloids, and then we discover that the non-metallic properties start to appear and then increase till we get the strongest non-metal, and then we have inert gases. So in periods, each period starts with a strong metal, except for the first period. Each period starts with a strong metal except for the first period. All the rest periods start with a strong metal, and then the metallic property decrease till we find the metalloids, and then the non-metallic property started to appear, and then till we get the strongest non-metal, and then the strongest non-metal exists in group 7a. You have to notice this. And after this we have inert gases. This for period. For group, okay, in group 1a the metallic property increases. In group 1a the metallic property increases. Okay, so again, by increasing the atomic number in periods, atomic size decreases, the metallic property decreases, and non-metallic property increases. But in group, the atomic size increases, the metallic property increases, and non-metallic property decreases.